Hi, good evening, everybody. How's everyone? Welcome to Heuristic Science Facebook Live. This week I'll be taking, this is Mrs Koh speaking. I think for the past few weeks, you all have seen various of our teachers. Hang on. All right, let me see. Hang on, guys. I just want to check that it is online, it is live successfully. If any one of you is watching, maybe just say hi to me. Yes, okay, I can see you all. All right, that's great. Because I just saw there's I have a error message, just wondering what's going on. All right, welcome everybody. Now, tonight we will be dealing with to me, it is a very abstract topic, okay? Energy. Now, to my audience who are watching live right now, do you like this topic? Maybe you can put in the comment. Let us know, do you like the topic of energy? Now, I'm talking about P6, energy conversion, not your P4, heat and light. Those are the much simpler ones. How about this P6 topic, energy conversion? Do y'all like it? Let me look at the comments. Now, those of you who are here, maybe you can also type in the comment. Let me know your name, okay? So glad to see you. Now, basically P6, right? There are two topics that are very abstract, okay? If you come back, right, I presume that I'm speaking to most of P6 audience and parents. P4, you have a very abstract topic called matter, then followed by light, not too bad. Then heat is hard. P5, probably, let me think, water. Then the difficult one will be electricity. Then when it comes to P6, right, we always find that these two topics, energy and forces, students find it very difficult to grasp because number one, you can't see energy. Number two, you can't see forces. All that you can see is things, stuff at work, and then we tell you that hey, there's energy in the objects. Forces has been exerted. So it's like, to us, this is called abstract. Okay. Hi, Clara. Okay, thanks for saying hi. Okay. I'm going to show you a P6 PSLE question. Then we are going to do quite a bit of discussion. I've chosen this question, right, because we can actually discuss beyond what the question have asked. Okay, let me show you the question first. Now, by the way, all our handouts, right, are placed in the Heuristic Science Telegram group. Now, why do we place them there? Because sometimes you might be watching some of our past recording and you're looking for the handouts. Just go to the Telegram group. All the handouts are stored there. Okay. Hi, Evan James. Welcome. Okay, let me show you the handout first. Okay, there you go. Okay. So to find the handout, just go to the Heuristic Science Telegram group. Any one of you need the link? I can place a link in the comment. Let me see. I have to copy. I don't remember also. Okay, maybe I'll just put it there, right? Hang on. Okay, there you go. Let me, no, I can't pin this. I think I can. Wait, cannot. Ash, hi Ash. All right, let's take a look at the question now. You probably have done this question. This is taken from 2022, okay, PSLE, and it's an energy conversion question. Now, when you are given an energy conversion question, right? Number one, children and parents, please advise your child that PSLE question, you really have to read the question very carefully. I know diagrams are interesting, okay? Students often just jump straight to the diagram without reading through the intro sentence, you cannot afford that. Okay, PSLE, you have to read the question very, very carefully. Okay, now let me run through the question with you first. Here and there, on and off, I will check the comment. If you have any question, anything you want to ask, just put in the comment. Okay, because when I am on the PDF, right, doing annotation, I can't see the comment, but I will like toggle back and forth. Okay, so not to worry. Let me go back to this. Okay, Peter has a flying bird toy. Okay, when he turns the handle, the rubber band becomes twisted and the plastic wing will move up and down. Okay, so take note of that. This is how the toy will move. Okay, and they even illustrate that for you. Next, Peter turned the handle 50 times and threw the toy into the air. The toy flew from A to B. Okay, look, A to B, right? It is going upwards. Okay, and Peter threw, right? He actually exerted a force, but the main force to allow this toy to move upwards, children, tell me, where does it come from? In order for the toy to move from A to B, where does the force come from? Let me just wait for some of your response. Now, every question that I ask you, right, it is to provoke your thinking, to really understand, because a similar scenario can always be changed a little bit and come out in PSLE again. Okay, don't go straight to the question. There are so much that we can actually use for discussion from a PSLE question. The part A, right? Later. Okay. Now answer my question first. A to B. Energy conversion. Yeah. Okay. Very good, Ash. It comes from the stretch or the twisted rubber band. Okay. What force is that? Now, energy question. Energy and forces, right? They are closely linked. I can use it to discuss forces as well. Okay. Tell me the force. I want the force. I don't want the object. You all are all answering me. Okay, object done already. Now give me the force. What is the main force? Yes, he threw, but what is the main force that push the toy upwards? Not a difficult question. Come on. This whole entire question now, we can convert it into a forces question actually. Okay, I'll just wait for a while. Dear children, I ask for force, you tell me energy. Gone. See? No, not push force. See, it's a very common problem, when the question asks for force, right? It is the tendency in student to give energy. Yes, very good, Ash. Thank you. Yes, he did throw. If he didn't throw it, you never know. The flapping, right? It could provide enough force. Okay, it could. It depends, but of course, if it's a much heavier toy, of course you need to throw. So, where is it? Okay, true. All right. So that is one. So if the question asks you, what are the forces that allows the toy to move from A to B, right? Your answer actually there are two. His push plus the ESF. Okay, the elastic spring force. All right. Just have to really think a little bit. So there are two forms there. Who's that? Christina Chua. Very good thinking. I like the way you are thinking. Science question, you need to think. All right. So after that, okay, the first part, I'm done already. And then, how about this portion? Tell me about this. What can we gather from here? Do not tell me what is obvious, okay, children? I want you to think a little bit deeper in terms of energy. Okay, let's talk about energy now. Don't tell me what is obvious. I tell you what is obvious. Obvious is it moved forward only, didn't move upward anymore. These are what I call obvious, but I want think a little bit deeper in terms of energy. EPE converted to into KE. Okay, very good. We crystal. What else? Yeah, at that point, right? Do you think the wing is still flapping? Is it still flapping? From B to C, still? If you read the question carefully, right, it didn't tell us how far that it can flap. What do you think? It has reached its maximum amount of KE? GPE, yeah. What about GPE? Tell me what about GPE? From B to C. HE, yeah, okay. When you move through air resistance, there will be some conversion to HE. Tell me about GPE first. No response? Or there's a lag. I wait for a while. Stays the same? Awesome. Okay. Yeah, at this point, right, GPE remains the same because the height never changed anymore. Okay, let me type that down, okay? GPE remains the same. Okay, awesome. How about KE? Is there KE? Is there still conversion to KE? Have? It is above ground. Wait. KE converted to GPE. Christina, you are wrong already. If KE continues, is there any more KE to GPE? Any more? If KE still, now we are going deeper already. If, hang on, if KE still converts to GPE, then that means my GPE should increase. I should not be remaining at this point anymore. Am I right? Okay, so there is no more, take note, no more conversion of KE to GPE. Okay, no more already. If there is, right, this thing should continue to move up. So GPE remains the same. The question, is the wing still flapping at this point, E to C? That it still continue to move at the same height this way. Is the wing flapping or not? This part is actually very important because this will help us to answer one explain question later on. Yes, good. The wing is actually still flapping, but you see, the twisted rubber band, right, 50 times. By then, probably is about time that is like fully untwisted already. Okay. I will say this question is actually not easy. All right. No more wing still flapping, but slowing down. Okay. All right. One more question for you before we start doing the question proper. Children, when did the wing stop? Roughly, when? See, if the wing still flapping, that means there is still EPE to KE to let it continue moving. All right. But there's no more conversion to GPE. Whatever GPE that the plane has, right, is already fixed. So now the conversion is just to allow it to continue moving. At the same time, listen, because of the air resistance, right, some of it is like continually, right, the KE is converting into heat and sound. Roughly when? Very good, Kai-En. Around. Exactly when? We don't know. Is it really at point C? Probably. Okay. So I will just take it like this is the part. Okay, when the wing stop flapping. How I know? Because after that, right, it start to go down. Right, stops flapping means no more. Okay, therefore, no more EPE to KE already. That also caused it to stop moving forward. Now, it did not stop moving forward straight away. Okay, let's say stop flapping here. How come it can still, like, it didn't like immediately dive? it still move like a little bit before it start to, how come? Final question. I got so many things to ask you. Oh, hi, Jasia. I can see your smile. So nice. All right, answer me. Let's say stop flapping at C, right? How come it still move a little bit? Yeah, good job. Always remember this portion, that something stopped already, but the object continues to move because it still has KE within it to allow it to move a little bit more. Okay, you cannot, guys, cannot use momentum. Please don't use momentum to explain. Okay, momentum is not in your primary school syllabus. Okay, it still move a bit because it still has KE to continue moving. Once that KE really like all converts into heat and sound, right? Very minimal. That's when it starts to drops. Okay. Oh, hi, Singler. Not like it's all converted to GPE. Not all KE. Singler, there's no more to GPE. You're wrong, okay? Because if there is still KE to GPE, like I said, listen, if there's still KE to GPE, that means GPE still increase. It should continue to go up. It did not go up anymore. Actually, from B onwards, no more KE to GPE. GPE become constant already. You get it or not? Okay. All right. I think we have very good discussion already. The C to D, we keep it later. Let's run through the question. All KE. Yes, that's right, Ash. Okay. It's still moving. KE then continue to move, convert into heat and sound due to the air resistance. All right. Now, this one, I'm sure all of you know how to do. Rubber band, okay, elastic, potential, energy. Okay. Now, look very carefully. PSLE, right, when it comes to energy conversion, they like to use these two words, which we seldom see that in school exam paper. They only want main forms. Okay. So you make sure you give the main form. The not main forms, right? The question has already given you sound. So from A to B, right? What energy does the toy have? What else? The other two. Okay. Yeah. Yeah, that's right, Singer. KEN. Wait. Hang on. KEHE. No. KE definitely. HE, right, is never a main form unless that device is using heat to work. Okay? Yeah, it's GPE and KE. Now, I want to say something later. I know why some of you did not use GPE. It should be kinetic. Okay, and this one should be, I know a lot of the school, they use potential energy. Go ahead, but I will still do gravitational potential energy. Now, because of the word main forms, I have to use GPE. The next thought that you might have, I thought it's KE to GPE, not KE plus GPE. Okay, some probably similar, you are having that thought. Here, right, it is not actually a conversion. If you look carefully, right, their conversion is just here. After that, the whole entire thing, right, they box it out. Okay, it's basically asking you at that point from A to B, what energy does the toy have? There's no longer needed to show the conversion itself. Okay, from A to B, right? It is moving, so KE. It is moving up, so and it is above ground, so it has GPE. Okay, are y'all okay? If didn't use main forms, yeah. If didn't talk about main forms, right, then yes, HE, correct. So always remember main forms. Now, let's put down a note here. So you guys got to be very careful when you get energy conversion, okay? Main forms means is the working energy. Okay? Heat and sound, right? It's not unless toaster, kettle, iron, sound toy that produce sounds. Okay, so you have to read question very carefully. Okay. All right, let's move on to the next question, which is an explain question. Explain why the toy flew lower and lower from C to D. Now, I prefer to do answer next to the question, so I will go back up to the previous page. Okay, lower and lower from C to D. What is the first thought that comes to your mind? Let me hear your answer. Why did the toy flew lower and lower? Energy, GPE decrease. Yes, GPE decrease. Yeah. Why? Now, KE was converted to heat and sound. Christina Chua, I think that's just here, right? That only explain KE decrease, move slower. It doesn't explain the lower. Lower means height related. You always have to use GPE. But is it just use GPE only? Hi, teacher Lowell. Thank you for coming in to support me. I have not done Facebook Live for so long. You can pause me. Sorry, Karen, you can't pause me. I'll continue to talk. Okay, let me see some of the response that is coming in. C to D, KE in the moving plane will be converted to heat and sound. Do you all remember one discussion that we did earlier? How come D to C it move, then after that it start to dive? You got to start from there first. All other GPE eventually converted to KE, okay? Plus other forms of energy. Okay, not bad, Jasia. Okay. Why? Now, energy conversion, right? Okay, wait, hang on. GPE converts to KE because it's dropping, okay? But now the question is asking you, why did it start to move? Why? You still haven't answered the question. Not yet. What caused it to, at first it's like that, then getting lower and lower and lower. Why? I thought that you guys would give me a very easy, so-called the easy, but it's a wrong answer, but nobody gave that. Very good. Sorry, we crystal is singular, right? Correct, right? Singular is you, right? No more EPE to KE already. Remember that part? Wing resistance, no. Because in order to maintain the height, right, the wing has to keep on flapping. The moment it stops, right, there's no more EPE to KE. No more EPE to KE, right, to keep moving forward. That is when the effect of what will start to kick in. You will see that effect. I mean, it has always been there, but now the effect becomes visible. All right, I will use what I think is what Singer has given. Okay, there's something special here. Okay, wait, wrong. Hang on. There is something special here. So this becomes my clue. Why? And also my final result is lower and lower. Okay, the R is lower and lower. Lower and lower meaning GPE decreasing. That means the point before this lower and lower, I'm using TCR now, is GPE decrease. Why did GPE decrease? Because here likely at this point, right, the wing has stopped flapping. Okay, and this will lead to no more EPE to KE to move forward. Okay, then once it cannot move forward, that is when it will start to drop. Okay, this thing I move later. GF. Now, I am not combining two together, but I'm showing you that because of GF, right? GF means gravitational force. Due to GF pulling it down. Now, children, GF is there all the while. All the while. But now, right, it becomes visible because of whatever happened previously. Okay? Causing, pulling it down. And when it's moving down, right, that is when GPE to KE causing, I'll write first, causing GPE decreases. Okay, and then okay, so this will explain the whole entire thing. Wait, my no more no spell wrong. Okay, are you all right? Wing resistance, right? There's no such thing. It's just air resistance. Whether wing or no wing, if object move through the air, right, there's air resistance. Ash, no. Take time to take in this, okay? All right, the final question is actually very easy. Double rubber band. Okay, double rubber band, you basically have more EPE, so you will go a little bit higher, a little bit further. Okay, that one very easy. Sorry, you all know I don't know what is it for. Now, throw at the same path. So basically go a little bit higher. You all know what to do, right? The last one. Let me use a different color. This one is quite easy. Okay, cannot use blue. That's also blue. Hang on, Okay. Okay. There you go. Go up. And a little bit further. Okay. All right. Interesting, right? Energy question. Okay. All right, children. This is what I have for you tonight. Now, next week, yeah, we should be doing Facebook Live every week. By the way, next week, I think some of you already heard our other teachers sharing. Next week, right, Monday, we are having our annual fiesta. two things will be happening. I will be conducting the real life scenario with the PSLE students. Okay, this is the chapter 2. Is some of you will be coming. I seen your name already. We are going to look at real life scenario based question. Example, like this is one of them, and there are many others, right? You probably have not seen it in any other resources because we did the question from scratch. Okay, something never seen before, and let's see how to handle them. You can, there's no QR code here. Anyway, you can find out from our Heuristic Science Facebook. And then on Monday, right, is our yearly fiesta. This is for the P3 to P5. Okay, you'll be doing, it will be held in SMU, hands-on experiment plus practice question in the morning. Then afternoon, y'all will be going out to Sentosa, this place called Santopia, to see how plum parts is being used in real life industrial application. And then come back to SMU with some booths, the Fiesta booth, for you to do more, not hands-on, but play to see science concepts. Okay, so these are all that's happening next Monday. And then Tuesday, we will come back for our usual Facebook Live. And then let's gear up towards PSLE already. All right. You can't go. It's okay. What time at Monday for P6? Let me see. I'm conducting 9 to 12, 1 to 3. It's a 3 hours in the morning, 2 hours in the afternoon, 1 hour lunch break. It's an online thing. Okay, it's a all real life scenario based questions and going through almost the whole entire syllabus. We do question from different topics, entire syllabus. Yeah, it is a little similar to the real life book that I wrote. Yeah, that one is a collection of all the real life scenario question, but this one is not replicated inside the book. Yeah, maybe only one question, electricity. So come and have a, I mean, if you have nothing to do, you got a lot of things to do actually. This is for your consideration, okay? If you all need any questions, right, you either go to our Facebook Heuristic Science website or you can text my admin, okay? I give you the number. Okay, here's a number. Just text our admin to find out more. All right. Thank you so much. You guys are awesome, okay? You are attentive throughout, as we discuss the not so easy topic, but it's fun. All right. So I hope to see you in the future Facebook Live. Yes, it is online. Yeah. And if you cannot come, need to go off for something, we can send you the recording. Save time from traveling. Yeah. Any other questions? Thank you so much. I'm so glad to conduct Facebook Live. Nowadays, I do a lot less, but we'll try to come on a bit more. Okay, bye-bye. See you.